Hello everyone, and welcome back to the Kohi game engine series. Today we're going to get started on the application layer and the main game loop, and we're going to get started right now. So before we jump into the video, I would like to take a second and thank the channel's partners, Eearslya and Wensheng. The partners are the highest tier of membership on the channel, so I thank you guys for your support. I'd also like to take a quick moment and thank everybody under the supporters section. All of you guys that are listed here on the screen, thank you very much for your support. It's greatly appreciated. If you're interested in supporting the channel, one way that you can do that is you can go ahead and click the join button below this video. If you'd like more information on memberships, I'll go ahead and post a link in the description below, as well as a card in the upper corner of the screen. With that stuff out of the way, let's go ahead and jump into it. Okay, so last time we set up our basic platform layer on Win32 and Linux. So what we have currently right now is our entry point is in main.c, and we are currently calling our platform startup and shutdown code from there, which is far from ideal. So what we really want is to set up an application that then references the platform itself, and the application to be exposed, not the platform, because we don't really want to be exposing platform specific stuff outside the engine if we can help it. We are going to accomplish this via what I'm going to call the application layer. And application layer is basically going to be, you can almost think of it as a singleton in a manner of speaking. It's going to be a state with a set of functions that go along with it that not only contains our game loop, but also contains some basic state information about our application. So that's what we're going to go ahead and do today. But before we jump into that, I wanted to kind of show you guys a little bit something special today. I was going to hold off on this, but I think it might serve as a good motivator for you guys to kind of see visually where we're going with this. So as I've mentioned in comments and I believe in prior videos, I have another sort of branch to this project that I am working on sort of in private so that I can test things out, see what works, see what doesn't. That way when it comes time to actually record these videos, I've got something worked out, I've got a plan and a structure to go with, and I can just go with that versus trying to figure all that out on the fly and having to do a bunch of refactoring. So what I wanted to show you was a little bit of that, what I'm going to call the development branch. And it's not technically a branch, it's actually a completely different repository, but nonetheless, it is the Kohi dev branch. And so what I'm going to do really quickly is I'm going to run this application just so you guys can kind of get a visual idea of some of the things that are coming down the pipeline. Now, if you pay close attention to what actually happens here, when we launch the application, you'll see some things happening. So not only do we have assets coming up on the screen, drawing, we've got some basic lighting effects in here. I still have a long way to go on that. We have models, textures, all that stuff loading. But if you noticed, we also have asynchronous loading of these objects happening. So we've got a full job system in place. And so all of these things are elements that we're going to be building on top of. So I'm not going to spend a lot of time on this, but I do think that it might be somewhat useful to you guys to be able to actually see some of this stuff in play. So I figured I would go ahead and just real quickly show you this with some test models in here so that you guys could get a visual idea of where the project is going. So anyways, that is that. Let's go ahead and jump into our application layer. So there's a couple things that we want to do. First, for the application, we want to create a couple basic methods, but we obviously need somewhere to house those. So under core, we are going to create a new file. We're going to call this application.h. Obviously, we will begin with our pragma once and defines.h include. Okay, and we're going to start off with two methods here. We're going to start off with a application create and an application run. And this is basically going to be the entire interface that runs when we start up the application. So it's a lot simpler. We don't have to worry about any platform stuff at this point. Now, when we create the application, currently if we look at what we're doing in main.c, we're actually passing in some information here, right? So we have the application name, and then we're passing an XY and a width and a height for our window position if we actually need it. So what would be nice is a way to be able to say when we start up the application what some of this configuration is. And so we're actually going to add that as well. So above here, just under defines.h, we are going to go ahead and create a application config struct. And this is going to take in our starting X and Y positions and a starting width and height for the windowing. And then, of course, our name of the application. So this is, of course, the application, the window title that's going to be used. So with that, in our application create, we're obviously going to want to take this in. So we are going to want to take in our config like this. Okay. So the next thing we're going to want to do is we're going to want to copy these two methods and create a new file under core, call it application.c. Obviously, we'll want to include application.h, paste in our methods, get rid of the KAPI, and now we'll go ahead and start filling these things out. There are a couple of things that we are going to want to set up here. So the first thing that I mentioned is application state. And I mentioned this is going to be sort of a singleton, which means there's going to be sort of one instance of an application that runs. So the way that we're going to handle that in this code is we're going to create a sort of static application state structure that we'll go ahead and hold on to. And that is where we'll hold sort of our global application state, as it were. So we're going to create a struct of type application state. And it is going to hold a Boolean for whether or not we're currently running, a Boolean for suspended. We'll come back to that in a bit. It's going to hold a pointer to the platform state, and then it's going to hold width and height and the last time, which is going to have to do with our game update. So we'll come back to that in a little bit. And actually, it's going to hold probably a lot more stuff. This is going to grow in size as the application does, but for now, these are the basic things that we need to put everything in place. Now, I mentioned that we have a sort of static state that we need, and so that is going to be a static variable, which makes it private to this C file, and that is going to be of type application state. We're just going to call it app state, and it's not going to be a pointer. We're not going to do any dynamic allocation, anything like that. We're just going to access this directly for any of the methods in here that we create or when we fill out these guys. So there is one more thing that we want to do, and we want one more sort of variable to track. And we could technically add this to the state, I suppose, but I'm not going to do that. I'm just going to add it here because there's really only one place we need to check it, and that's it. And I don't necessarily want to pollute the state with that. So this is an initialized Boolean. And basically, this is just a safety check that if we happen to call application create more than once, this is actually going to cause a failure of that. And what I mean by that is this. So we simply look at that initialized and say, hey, if we've already initialized, let's throw an error and return false. Now, if this returns false, that means that the application could not be started and the program will actually wind up exiting. So with that, we actually have a couple of things here that we have not imported. So we have our K error here, which is out of our logger, and then we have the platform state, which is out of platform. So we need to go ahead and add an include for logger.h and an include for platform.h. So now that we have those things, there is a couple of things that we need to bring out of here. Now, one thing that I noticed is we're not actually doing this in main.c, but our logger actually does have this initialized logging function that we're not actually calling anywhere. So we actually need to make a call to this guy because we are going to be standing some stuff up here very shortly. So back in application C, the very first thing that we are going to do here is initialize logging. And I'm actually just going to put a comment here that this is where we're going to initialize our subsystems. So we're going to have a lot of subsystems throughout the engine, and we're going to cover those individually. This is one of those subsystems, and that type of initialization happens as we create the application. So the other thing that we have is we have this test code here for our logging. Let's get that out of main. And for now, I'm just going to move that also over here to after initialize logging. We can always remove this later. In fact, I'll put a to-do in there to remove that, but we want to leave it in place for now because we actually have some enhancements that we want to make to the logging system that we're going to want those for. So I'll go ahead and move those over there. And the next thing that we're going to do is we're going to set a few of these items for application state here. So we're going to say, first off, that application state dot is running is equal to true. And that's basically saying, okay, we're running the application now. And we're going to say application state dot is suspended is false. Now, suspended is sort of a state that our application can enter when we shouldn't be updating or drawing or basically doing work on the application. And this can include things like when we minimize, or maybe on certain platforms like Android, for example, where we've switched to another task or another application where we can't be occupying resources. We need to actually completely pause the application. Suspended is where we do that. So it's going to be a bit before we actually tie that in, but we want to go ahead and get the flag in there for it now so that when we go to actually tie that in later, it makes things a lot easier. So the next thing we want to do is back in main.c, we want to strip out this platform startup code. And I'm actually going to grab this platform shutdown as well. So I'm just going to cut that out of here and go back to our application and paste it down here. Okay. And we're actually going to get rid of this state here because we're actually going to use the one that's up here. And actually, I just realized I made this a pointer. It should not be. It does not need to be a pointer. So we're actually going to use this platform state here. So we're going to change this to app state dot platform, and we're just going to pass the address of that. And then instead of passing all this hard-coded data, we are actually going to pass in our configuration. So we have our config dot name, our config start position X, config start position Y, and this is actually going to get too long for one line, so I'm going to split this up. Okay, so we have our config start width, and finally our config start height. Okay, and this is where our platform startup is going to be. Now, we are actually going to move this while loop that is here, which is technically sort of our first iteration of our game loop. We're going to take this out of this if check, and for right now we're going to paste it in application run. We'll come back to this. Okay, so if our platform startup is successful is basically what we're checking here. We want to do something. However, we're going to invert this to say if it's not successful. So if it's not successful, we want to just return false. Okay, so that is pretty much the platform startup change. So the next thing that we need to do is take this platform shutdown code, and we're actually going to put it outside our while loop here after that. So whenever this loop completes, we will go ahead and shut down the platform. Okay, so the last thing that we need to do in our application create is we need to mark our initialized flag as true. And then we need to return true. Now, this is obviously a very simple setup. This is going to grow quite a lot as the application does, but this is where we're going to be doing all of our initialization from going forward, except for game-specific code. Okay, so our application run, as I said before, this is where our game loop will actually be. So when we call application run, the application is going to continuously be in this function for the rest of its life until the user actually chooses to quit. And that is because our game loop is right here. However, right now this is hard-coded to sort of just do a while loop forever, while true, basically, and we don't want that. So we need to change this to app state is running to say basically while our app state is running, we want to loop. But if it's not running, then we don't want to loop. And so if for any reason, if you recall, when we set up our platform pump messages, it returns a Boolean. So if for any reason this returns a Boolean, we actually want to break out of this message loop. So, or the game loop rather. So we're going to go ahead and do a check now properly on this to say if not platform messages, or in other words, if it returns false, then we are going to go ahead and set app state dot is running to false. Now, obviously, this does not have the state, so we'll need to pass it the address of app state platform, which is our platform state. And we'll need to do the exact same thing down here for platform shutdown. The next thing that we will go ahead and do is if for some reason we exit this loop without having set this to false, we want to absolutely make sure that that is set to false, just so that anything that checks it at this point during the shutdown process actually has the right information there. So we're going to go ahead and explicitly set that to false. Okay, so next we call platform shutdown, and then our application run at this point would return true. And so for now, that is our application setup, at least for right now. Like I said, we are going to be expanding on this, but for now, that is it. So back in main, we are going to get rid of platform.h because we don't want that anymore. And in fact, in platform.h, before we update main, I want to get rid of the export of platform startup and platform shutdown, as well as platform pump messages, because we don't want any of this stuff exported anymore. We don't want to be able to call this from user code. Okay, so back in main.c, we want to include core application.h. And this will actually be changing somewhat too, but for now, just to make sure that everything is actually hooked up properly, we're going to go ahead and do it this way. Okay, so the first thing that we need to call, obviously, is our application create. But to do that, we need an application config. So the way that I'm going to do this is I'm actually going to copy all of this, go back to our main.c, and just paste it all here. And I'm going to just change this to a declaration, right? So we'll just call this config. And to make this explicit, we will set our config start position X to 100 as before. And then we will do the same for Y. Now that we have our configuration, we are simply going to call application create, right? And we're going to just pass through the config. And then we're going to call application run. Okay. And this actually takes a pointer, so I need to pass the address of config. And let's go ahead and build this. Okay, and we'll run. And we can see here that our application is running as expected. So again, it doesn't feel like we've accomplished much here, but actually we have set up a better structure for our engine than just directly relying on our platform code. Okay. All right. So the next big piece that I want to handle is I don't want user code to have to be concerned with creating and dealing with input parameters and so forth from a main function. So I don't want user code to have to worry about creating an entry point or dealing with arguments or anything like that. I want to have the engine handle all that and be able to eventually expose some utility methods to user code to be able to handle those things gracefully. So what we're actually going to do is we are going to take the main out of the user code, and we are going to put the entry point of the application into the engine DLL itself. And then we are going to create, we're going to invoke that from our executable by externing it. So basically what this means is the only thing that the executable is actually going to contain is just functions specific to the executable that it needs. It doesn't have to worry about calling application create and application run and all this startup code, right? This is not a great way to have to work with an engine, right? You shouldn't have to do all this. You should be able to basically define some configuration and pass it off and say, okay, engine, do what you need to do to start up, and then we're good to go, right? We shouldn't have to call all this. So we're going to change things up a little bit. So the first thing that we want to do is, as I mentioned, we want to get rid of this main function out of here. But to do this, we're actually going to need to do a couple of different things in our... So as we've discussed in our architecture of Kohi, the executable is basically going to be referred to as a game. So we need a structure that is capable of giving us a description of what a game looks like, or providing us an interface, if you will, as to what the actual game should contain in terms of what functions it should have to be called, how it stores state, configuration, things of that nature. And so that is the first piece we are going to create up here directly in source. So this is sort of the root source folder. We're going to create a new file, and we're going to call this gametypes.h. And gametypes.h is going to pragma once, obviously, and then it is going to include core application h. And what we're going to do is define sort of what our game needs to provide in terms of how it needs to run. So we want to basically declare what the structure of our game should look like on a high level. And to do that, we are going to typedef a new struct called game. This game will contain our application config that we defined in application h, and it's going to have some function pointers. So we're going to have a function pointer to an initialize, so that the engine can call the game and say, hey, do whatever you need to do to initialize yourself. There's going to be an update, a render, an on resize, which is basically for window resizes, and then a void pointer to its internal game state. So this is basically what a game will look like to the engine. We want to keep this interface as simple as possible so that there aren't a lot of entry points into the game from the engine. Okay, and that is it for game types. We just need to sort of declare that. Okay, so the next thing that we need to do is, again, under the source folder, we need to create another new file, and we're going to call this one entry.h. And entry.h is going to include a couple things. It is going to include the core application, the core logger, and gametypes.h. Next, it is going to include the definition of a function that will be defined in user code. And this is a little bit different than anything that we've seen up to this point. So we have xturn b8 create game, and then we have a pointer to a game that we're saying is out game. So what this is doing basically is it's telling the compiler that we have an externally defined function to create a game. So this xturn keyword is basically saying we have included this in some other either library or executable that is going to be calling this code. It's defined elsewhere. So don't worry about its definition. It's defined outside the context of this particular assembly that's being compiled. Just know that it returns this type and looks like this. And so this is going to be defined over on our main.c here in a moment. So this is the critical piece to being able to move main, this function, out of our user code. Okay. Speaking of which, back in entry.h, we are actually going to take main.c and cut out the main function, and we're going to place that in entry.h. So this is now the new main entry point of the application. I'm actually going to mark it as such. And so this is where our main function is actually going to sit, so that we no longer have to define it here in this code. The next thing that we're going to do is we're actually going to have to move some stuff around here. But before we actually do that, we want to go ahead and request a game instance from the application by calling this, right? So the first thing we need is a game instance variable, something to actually hold our game instance. And then we're going to go ahead and call our create game that's externally defined. Bear in mind, again, our engine DLL does not know how this is defined. It just knows that it's defined externally. Okay. And so we're saying, go ahead and call that externally created function and pass it the address of game_inst here to be filled out. And if that returns false, then we have a fatal error of some kind on the game side, and we actually can't proceed. So we're going to return -1. Okay. So this is going to set up our game for us. All right. So the next thing that we want to do is, as I said before, we actually have in our game types, we have these function pointers here, right? So we actually want to be sure that the game has set these things appropriately. Because if those are null and we go to call them, obviously that's going to be a problem. So we want to ensure that those function pointers actually exist. So we're going to check that render, update, initialize, and on resize are all assigned. They must be assigned by the game. So that is really one of the only requirements that the game has, is it must fill out these things. So I'm just going to snip this out of here and move it down below here just for a second, because we're actually going to be moving it out of here entirely. Okay. So the next thing that we're going to want to do is our application create takes our config, which I've just moved down here and said we're going to move out of here. So what we actually need to modify this to take instead is our game instance, right? And so our application create actually needs to be modified a little bit. So if we go to our application create definition, or declaration rather, right now we're taking a pointer to an application config, which is not really what we want. So now that we have the new game types, we want to include gametypes.h. And instead of application config here, we're going to take a pointer to a game and say game instance. Okay. And now in application C, we're going to change this obviously to match that definition. And so our application doesn't yet know anything about a game. So obviously we need to add a definition for that. So I'm actually just going to go in here to our application state and add a pointer to a game instance. We'll call it game_inst. Right after we check our initialization, but before we actually initialize our logging, we're going to go ahead and set the instance, right? So we're going to say app state.gameInstance equals game_inst. Okay. And we'll just reference this going forward, right? So now we have our game instance. Okay. Down here in our config section, we just need to change a couple things. So the way that our structure looks now is we have app config is our application config, right? Before we were calling just config. So now we actually need to change this. I'm actually going to column select here and say game_inst and then app_config. Oh, and then since our app config is no longer a pointer, we'll need to change this to just dots all the way down. Okay. So this is basically just a direct pass through of those properties. So the next thing that we're going to want to do is we're actually going to want to call into our game's initialization routine. So to do that, we simply call app state game_inst. And then since it has a function pointer to initialize, we can just call that directly. And then we pass through our game instance itself, which if you recall is just a pointer to our application state's game instance, right? And so if for some reason initialization fails at the game level, that's a fatal error here. And so we log that out and return false, and that aborts this process. Okay. So the next thing that we want to do is go ahead and hook up our onResize event, or I should say our event handler. And I know that we haven't actually declared this because we haven't handled window resizing, but I want to put this plumbing in place now so that the game instance actually gets notification as to when the window resizes, and as to what those new dimensions are. So whenever we get to handling that part, we're basically going to set the app state width and app state height to that new resized value, and then we're going to go ahead and call this. Okay, and then all the rest of this is the same. Here in our application is where we're actually going to be adding a little bit more stuff. So right now we are basically just pumping platform messages and not really doing anything else. So the next thing we want to do is actually do a check to say if app state is not suspended, then we want to actually do some other stuff. Most notably, we want to call our game inst update function pointer. Right, so we want to run the update routine. Now we are passing a 0 here. This is for the delta time. We don't have delta time yet. That is something we are going to come back to shortly. So for now we are passing 0 here because we don't have that, and I'll explain what delta time is when we come back to that. But for right now, let's just take that at face value and accept that we're just basically hooking up some plumbing right now. So the game had a update routine. It also has a render routine, which looks almost exactly the same. Change that to render. So again, if render, just like if update fails, then we want to break out of the application because something has gone wrong. Okay, so that does it for the application updates to support the game. Now, we have a couple more pieces unresolved here in application create. So first off, application create actually returns a Boolean, but we're not actually checking it. So that's the first thing that we need to do. And if it fails for any reason, we want to go ahead and log that and return appropriately. Next, we no longer have the config here. So we actually want to pass the game inst instead, or more accurately, the address of the game instance. Okay. And then our application run also returns a Boolean, and if that returns false for any reason, we also want to log that out as well. So we're going to go ahead and check that. And basically all we're saying here is if that returns false, it means the application did not shut down gracefully. And actually I have these new lines in here. I don't really need those because the logger handles that for us. Okay. So we have our application create, our application run. This kicks off our game loop. So you know what? Let's actually snag some comments in here just to make this a little bit more obvious as to the life cycle of the application. Okay. And then, of course, we have our return 0 here. So now we're left with our application config, which is sort of just dangling in place here. What do we do with this? Well, I'm going to cut it out of here, because it no longer belongs in here, because we actually get that from our game inst. So we have this externally defined create game that so far we haven't actually defined. So we need to do that in our user code. So I'm actually going to take main.c here, and I'm going to rename it to entry.c. because that is more accurate as to what it actually is. Okay? And we are going to define our B8 create game, right? Which takes in a pointer to outGame, which is basically what we're going to be filling out. And this is where our application config sits. However, we don't need this guy anymore because outGame actually includes that. So similar to how we did an application, we're just going to change this to actually use the pointer. So this is going to be out game app_config. And then it'll set all these properties. Okay. So we'll go ahead and mark this as our definition of our function to create the game. And from there, we don't need this application anymore, right? That's our test code. We actually don't need the logger or asserts anymore, okay? We do need entry.h, and remember we're using angle brackets here to denote that we are importing from the engine, not something locally, okay? And we're actually going to need to define a couple of other things, right? Because if we look at our game structure one more time, we've defined sort of what our config looks like, but we haven't defined these other things, right? We actually need to set some stuff up for this. And so under source, we are going to create a new file, call it game.h. And this is actually where we're going to sort of stub out our game code, if you will. So the first thing that we're going to do in our game.h is obviously pragma once. We are going to include defines and include game types because we need those things. The next thing we're going to do is we're going to create a basic game state structure, which we are going to come back to in just a moment. But for right now, it's just going to hold that delta time value that we pass in our update and render. And we're going to create our 4 methods, our game initialize, game update, game render, and game on resize. So if we take a look at our game types one more time, you'll notice that these are called initialize, update, render, and on resize. So it may not be immediately clear, but the name of these functions doesn't actually matter. What matters is that their return types and the parameter types all match, and the number of parameters. So as long as these things match, which is known as the function signature, the function pointers can be pointed to these functions, right? So even though these are called game on resize, game render, game update, these could be called anything, and still this could be assigned to point to those functions, okay? So I've just sort of named them this to make it clear that these are the game versions of those particular functions. We need a new file, and we're going to call this game.c. Obviously, it includes game.h. For good measure, we'll go ahead and include the logger as well. And I will go ahead and define those 4 functions. Now, for now, they're not actually going to do anything, but we need them to actually be defined and at least return true so that we can actually start up the application successfully. So we'll go ahead and fill these out in a bit. So now that we have that set up, how do we link these or these to our game function pointers here? Well, in entry.c, we basically fill them out as an additional property to outGame. Our entry.c will now include game.h, which gives us access to these functions here. And to this, I'll just add assignments for each one. So game update is assigned to outGame update. Same is true for render, same is true for initialize and on resize. Okay, so we're almost done. The last thing that we have to worry about is this state. Now this is a void pointer, and our void pointer basically allows us to assign any type here whatsoever. And the engine does not know or care about it, it just knows that it exists and that's it. So what do we do with this? Well, we will need to, if we recall here, we created a struct for a game state. And this is actually what we are going to assign to our outGame state, right? However, if we look at our platform code, which is how we do our allocation, we don't have a way to point to this yet. So what I'm going to do is, this is very temporary because again, we don't want to be pointing to platform code, but we will be revisiting this as I'm temporarily going to expose platform, allocate, and platform free. We are going to provide a nicer interface to these functions instead of having to go through the platform code. But for now, we're going to use these because we don't have that interface yet. So back in entry.c, we are going to create our game state by, well, first including, oops, platform.h. And I'm going to put a to-do there to actually remove that so we don't forget to remove it, because we don't want to be, again, including our platform-specific code here. So our state, we need to basically platform allocate, and we want the size of game state, and aligned, we're just going to say false. Okay. And again, alignment is not something that we should have to care about in user code. It's something I've not explained yet. I realize that. So just take this at face value for now. So we're going to allocate a new game state of type game state and assign it to our void pointer here. And that is it. That's how we create our game state. So last but not least, we return true, indicating that all of this has been successful. Now we can have some additional initialization in here. It's up to the user from that point, but this is basically the only part that user code has to sort out for now. Eventually this interface will also be improved to just take in basically a configuration file, but again, we don't have that stuff for now. So for now, this is how we're going to do it. So I believe we've covered everything that we need to cover. However, just to prove that all this stuff works, I actually want to do a couple of logs here. Okay. So I basically want to say, you know, game initialize was called, which is a way for us to sort of validate that all this works. So I'm going to build, looks like we have an error. So I made a couple goofs here. First thing is entry.h needs a pragma once. And then I accidentally created a circular dependency between game types h and application h. Game types h was included here because of this, and this should technically be for declaring this instead. So we're going to change this to a struct, and then get rid of this include and say struct game there. And that will allow us to forward declare that. And then in the C file, we can then include gametypes.h. So if we build this now, we should be good to go. It's easy to miss things like that sometimes. All right, so let's go ahead and run. And now we are successfully running. And we'll see we have an additional debug message here, game initialize called. So our application layer is now successfully in place. We've properly created the concept of a game and gone ahead and initialized that properly. We've moved our entry point from our executable to our DLL and are now pointing to that properly. So now our application is starting to sort of resemble the original architecture that I had discussed. And so with these things out of the way, now we can move on to setting up some of the other systems and so forth next time. So that's going to do it for this video. Please do me a huge favor and hit the like button. If you haven't already, consider subscribing. It really helps me out. Hit the little notification bell to get notifications as to when the next video in this or other series drops. And I will see you guys next time.